You must have come across lightning rods on several occasions, but have you ever wondered how they work to protect buildings? The working of a lightning rod system is not just interesting, but equally important, considering that your life and property are at stake when it comes to lightning strikes. Did you know? The Empire State Building is struck by lightning 100 times a year on an average, and yet, it stands tall. Courtesy, an efficient lightning protection system at work. When lightning strikes a building, it resorts to any conductor available inside the building to make its way to the ground. In most cases, this is facilitated by electrical or cable lines. At times, however, the house itself can act as a conductor. When lightning passes through these lines, it can damage electrical appliances and may even cause fire and destroy the building. If we take into account the threat lightning poses to human life and the fact that we can't prevent it, our best bet is to avoid it, and the easiest way of avoiding it is to guide it to the ground by a designated path, such that it bypasses the building without harming it. Now, that's where a lightning rod system comes handy. It intercepts lightning and sends it to the ground using conductive material. The first of its kind lightning rod was the Franklin rod-appointed lightning rod conductor, which was developed by Benjamin Franklin somewhere between 1749 and 1752. The working of the Franklin rod was simple. To put it in Franklin's own words, the electrical fire would be drawn out of a cloud silently, before it could come near enough to strike. One problem with the Franklin rod was that it was not grounded and thus, didn't work well. That problem was eventually solved with the invention of the first grounded lightning rod by Czech scientist, Prokop Divis in 1754. A lightning rod system, a lightning protection system to be precise, is specifically designed to protect structures from lightning strikes and resultant damage. It is made up of the lightning rod, which is an inch-thick pointed metal rod, conductor cables, and ground rods. So the lightning rod is just a part of the system, and both, conductor cables and ground rods, play equally important roles in diverting lightning to the ground without causing any damage to the building. That lightning rods discharge clouds and thus prevent lightning is one of the most circulated myths pertaining to the lightning protection system. It's worth noting that the lightning rod neither attracts lightning, nor repels it. Like we said earlier, it just intercepts the lightning strike and guides the electrical charge to the ground via conductor cables and ground rods, thus protecting the building from heat damage and fire associated with this natural hazard. In other words, when lightning strikes, it seeks the best possible path to reach the ground, which in this case is via the lightning protection system. The best possible path or conductive pathway is made of thick conductor cables, which are usually made from copper or aluminum. Of the two, copper is preferred because of its remarkable current carrying capacity. By diverting electrical charge to the ground via a conductive pathway, these cables prevent the heat damage that can be caused to non-conductive materials if they come in contact with it. Many people believe that surge protectors provide effective protection from lightning strikes, which is far from true. Surge protectors are designed to provide protection from voltage spikes associated with everyday power surges. If at all, they can protect electrical equipment from distant lightning strikes. However, a direct lightning strike can render them useless. Surge protectors cannot replace lightning rods. Similarly, the structural steel of a building will pass lightning to the ground, but it is also likely to damage the electrical system, as lightning's electrical charge while seeking a path will jump from one object to another. It's important to understand that a lightning protection system helps in protection of buildings from lightning strikes and not in preventing such strikes. And that's only when it is installed properly. It is difficult to predict when and where lightning will strike, though tall buildings are particularly vulnerable to this natural hazard. If we don't see lightning rods sticking out of skyscrapers nowadays, it's only because architects have found some creative ways of incorporating the lightning protection system in their designs. The basic working mechanism, though, remains the same.